Multiply this with 1. 1 into lambda square is lambda square minus 5 lambda plus 4. Again multiply by minus lambda. Minus lambda into lambda square is lambda cube. Minus into minus plus 5 lambda square. A cube minus 6a square plus 11a minus 6i is equal to 0. Multiply by A inverse on both sides for equation number 2. A square minus 6a plus 11i, that is A square into A inverse, 6a A inverse, 11i A inverse. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today in this session, I am going to take very important problem based on Cayley-Hamilton theorem. So in previous class, we have discussed a problem for 2 rows, 2 columns. In this session, I am going to take problems based on 3 rows and 3 columns. Straight away, move to the first problem. This is very important problem for 10 marks. You may expect this type of question for 10 marks. Verify that the matrix A is equal to 1, 0, minus 1, 1, 2, 1, 2, 2, 3 satisfies its characteristics equation. Hence, find A inverse. That is, and also verify the Cayley-Hamilton theorem. So, in the examination, they may ask, verify that the matrix A is equal to 1, 0, minus 1, 1, 2, 1, 2, 2, 3 satisfies its characteristics equation and hence find A inverse. Also verify Cayley-Hamilton theorem. So, to verify Cayley-Hamilton theorem, so we should have to find the characteristics equation. Now, let us find out the characteristics equation. The characteristics equation is determinant A minus lambda is equal to 0. Determinant of A minus lambda is equal to 0. Now, what is that? A minus lambda I. What is matrix A? A is equal to 1, 0, minus 1, 1, 2, 1, again 2, 2, 3, minus lambda into an identity matrix of order 3 rows, 3 column is 1, 0, 0, 0, 1, 0, 0, 0, 1. Simplify this. So, that's equal to the matrix 1, 0, minus 1, 1, 0, minus 1, again 1, 2, 1, 1, 2, 1, and 2, 2, 3, 2, 2, 3, minus multiply by lambda. Lambda 0, 0, 0, lambda 0, 0, 0, lambda. Simplify this. Now, A minus lambda I is equal to 1 minus lambda. This is 0 minus 1 as it is. 1 minus 0 is 1. 2 minus lambda, again 1. Again 2, 2 and 3 minus lambda. Now, determinant A minus lambda is equal to 0. That is determinant 1 minus lambda 1, 2, again 0, 2 minus lambda 2, minus 1, 1 and 3 minus lambda is equal to 0. If you simplify this, if you expand this 3 rows, 3 column with respect to first row, you are going to get an equation. That equation is called the characteristics equation. Now, simplify. So, this is plus, minus and plus. So, that's equal to 1 minus lambda into 2 minus lambda into 3 minus lambda, minus 2 ones are 2, again minus 0 into any number is 0, minus 1 into this row and column is deleted, 1 into 2 is 2, minus 2 times 2 minus lambda is equal to 0. So, this is 1 minus lambda into, simplify this. Now, just multiply these two. 2 into 3 is 6. 2 into minus lambda is 2 lambda. Minus 3 into lambda is 3 lambda. Minus into minus plus lambda square minus 2. Minus 0 as it is. Minus 1 into 2. Multiply by negative sign. 2 2s are 4. Minus into minus plus 2 lambda is equal to 0. Now, simplify this. So, this is 1 minus lambda into, put it in order, lambda square. Minus 3 minus 2 is minus 5 lambda, 6 minus 2 is plus 4 into minus 1 as it is 2 lambda, minus 4 plus 2 is minus 2 is equal to 0. Again, multiply this with 1. 1 into lambda square is lambda square minus 5 lambda plus 4. Again, multiply by minus lambda. Minus lambda into lambda square is lambda cube, minus into minus plus 5 lambda square, minus into plus it is minus 4 lambda, again minus 2 lambda, minus into minus plus 2 is equal to 0. Now put it in order, minus lambda cube, how many lambda squares are there? 1 lambda plus 5 is 6 lambda square, and lambda values, how many lambda values are there? So minus 5, minus 4 is minus 9, minus 2, minus 4, minus 5 and minus 9, that's equal to minus 11 lambda. 5 plus 4 is 9, 9 plus 2 is 11, minus 11 lambda, and the constant 4 plus 4 and plus 2, 4 plus 2 is 6 is equal to 0. Now multiply by negative sign, you will get lambda cube minus 6 lambda square plus 11 lambda minus 6 is equal to 0 is the characteristics equation. Hope you followed, right? So hence the characteristics equation is lambda cube minus 6 lambda square plus 11 lambda minus 6 is equal to 0. Now, therefore, the characteristics equation is, therefore, the characteristics equation is lambda cube minus 6 lambda square plus 11 lambda minus 6 is equal to 0. Now, if you solve this, you are going to get the eigenvalues or characteristics roots. Now, suppose to verify Cayley-Hamilton theorem, let me verify Cayley-Hamilton theorem and then we will go for the inverse. Now, to verify Cayley-Hamilton theorem, put lambda is equal to A and multiply by I to verify CH theorem. To verify Cayley-Hamilton theorem. Right. Now this becomes A cube minus 6A square plus 11A minus 6I is equal to 0. Let us represent this as equation number 1. Now, so if A cube minus 6A square plus 11A minus 6I is equal to 0, then Cayley-Hamilton theorem is verified. Now just find out the value of A cube, A square first. A square is equal to A into A. What is the matrix A? Given matrix 1 0 minus 1, 1 0 minus 1, 1 2 1, 1 2 1, again 2 2 3 into 1 0 minus 1, 1 2 1, 2 2 3. Now simplify this. So this is equal to first row, first column, second column and third column. 1 ones are 1, again 0 into 1 is 0, again minus 1 into 2 is minus 2, again 1 0 0, again 0 into 2 is 0, again minus 1 into 2 is minus 2. So first row and last column, 1 into minus 1 is minus 1, plus 0, minus 1 into 3 is minus 3. This is first row. Now second row, first column, second column, third column. 1 into 1 is 1, again 2 into 1 is 2, again plus 1 into 2 is 2, second row, second column. So 1 into 0 is 0, 2 into 2 is 4, again 1 into 2 is 2. Again second row, last column. 1 into minus 1 is minus 1, plus 1 into 2 is 2, plus 1 into 3 is 3. Again last row, first column, second column, third column. So 2 into 1 is 2, again 2 into 1 is 2, 3 into 2 is 6. Third row, second column, 2 into 0 0, again 2 into 2 is 4, again 3 into 2 is 6. Last row, last column, 2 into minus 1 is minus 2, again 2 into 1 is plus 2, plus 3 3s are 9. This is equal to A square can be written as 1 minus 2 is minus 1, 2 plus 2 plus 4 plus 1 is 5, again 6 plus 4 is 10. First row, first column, second column minus 2, then 4 plus 2 is 6, again 6 plus 4 is 10, again minus 1 minus 3 is minus 4, then 3 plus 2 is 5 minus 1 is plus 4, again minus 2 plus 2 gets cancelled, 9. This is the value of A square, right? Now find out the value of A cube. Now A cube is equal to A square into A. What is A square? A square is minus 1, 5, 10, minus 2, 6, 10, minus 4, 4, 9 into A. What is A? A is the given matrix 1, 1 and 2. Again 0, 2 and 2. Again minus 1, plus 1 and plus 3. Simplify same as that of the same first row, first column, second column, third column. So first row, first column, second column, third column. So if you simplify, what is the answer you are going to get for this? You are going to get minus 11, minus 12, minus 13. This is AQ. Same first row, first column, second column, then 19, 20 and plus 13. That is second row, first column, second column and third columns. If we simplify, first row, first column minus 11, first row, second column minus 12, first row, third column minus 13. Second row, first column 19, second row, second column 20, second row, third column will get 13. Similarly, third row, first column, second column, third column. What is the answer we are going to get? So if you simplify, you are going to get this as 38, 38 and 27. Right, this is AQ. Now to verify Cayley-Hamilton theorem from equation number 1, from 1, what is 1? We have AQ minus 6A square plus 11A minus 6I. Substitute here. This is AQ. What is AQ? Minus 11 minus 12, minus 11 minus 12 minus 13. Again 19, 20, 13, 19, 20 and 13, 38, 38, 27 and 27. Okay. Now minus 6 times A square. What is A square? A square we have minus 1, 5 and 10, minus 1, 5 and 10, minus 2, 6, 10, minus 2, 6 and 10, minus 4, plus 4 and 9. Now plus 11 times A matrix. What is A? A is equal to 1, 0, minus 1, 1, 0, minus 1, 1, 2, 1, then 2, 2, 3. Next minus 6 times I, 1, 0, 0, 0, 1, 0, 0, 0, 1. So if this is equal to 0, then Cayley-Hamilton theorem is satisfied. Now that's equal to, just keep this, minus 11, minus 12, minus 13, 19, 20 and 13, 38, 38 and 27. Multiply by 6. 6 ones are 6, 6 twos are 12, 6 fours are 24, minus 24, 6 fives are 30, 6 six are 36, 6 fours are 24. Again this is 60, 60 and 9 into 6, 54 plus 54 plus multiply this 11, 0, minus 11, 11, 22, 11, 22, 22 and 33 minus 6, 0, 0, 0, 6, 0, 0, 0, 6. Now if you simplify this, what you are going to get? So subtract these two. Minus 11, minus into minus plus 6, plus 11, minus 6. Straight away write. Second element, minus 12, minus into minus plus 12, plus 0 and minus 0. Third elements, minus 13, again minus 13, minus into minus plus 24, again plus into minus, minus 11 plus 0. Next second row, 19, 19 minus 30 plus 11, then minus 0. Next 20, 20 minus 36, again plus 22 minus 6. Right. Next last element, that is 13 minus 24, again plus 11 minus 0. And the last rows, 38, 38 minus 60 plus 22 and minus 0. 38 again, 38 minus 60, again plus 22 and minus 0. Last element, 27, 27 minus 54, then plus plus 33 and minus 6. So if you simplify this, what is the answer you are going to get? See, this is equal to, I will write here. So plus 11 minus 11 gets cancelled, plus 6 minus 6 gets cancelled, 0. Again 19 plus 11 is 30, minus 30 plus 30 is 0. Again 38 plus 22 is 60, plus 60 minus 60 gets cancelled, 0. First column 0, 0, 0. Similarly, second column minus 12 plus 12 gets cancelled, that's equal to 0. Again minus 36 minus 6 is minus 42, plus 20 plus 22 is plus 42, minus 42 is 0. Again 38 plus 22 is 60, minus 60, this is also 0. Again last 24, minus 13 minus 11 is minus 24, plus 24 gets cancelled, 0 here. Again plus 13 plus 11 is plus 24, plus 24 minus 24 is 0. Again what is this equal to? Plus 27 plus 33, that's equal to 60, plus 60 minus 60, this is equal to 0. So totally a cube minus 6a square plus 11a minus 6i is equal to 0. Now since a cube minus 6a square plus 11a minus 6i is equal to 0, therefore Cayley-Hamilton theorem, CH theorem, is verified. So if you do this much, you will get 10 marks. So if you verify Cayley-Hamilton theorem, so just find out the characteristics equation and verify Cayley-Hamilton theorem for a 3 rows 3 column matrix, definitely you will get a 10 marks question. So you will get definitely 10 marks from this. Now to find the inverse, now let us take from a cube, that is from equation number 1. What is equation number 1? We have a cube minus 6a square plus 11a minus 6i is equal to 0. Now just multiply by a inverse, on both sides. What happens? This is a cube into a inverse minus 6a square into a inverse plus 11a inverse minus 6i a inverse is equal to 0. Right. Now that is equal to, this can be written as a square into a inverse minus 6a into a inverse plus 11 times a inverse minus 6i a inverse is equal to 0. You know this A matrix into identity matrix is equal to same matrix, or A matrix into inverse or inverse into a matrix is equal to an identity matrix. A into I or I into A is equal to A inverse or A inverse A is equal to an identity matrix. So this is A square into an identity matrix, 6A into A inverse is an identity matrix, 11A inverse is equal to an identity matrix. Again minus 6 I into A inverse is equal to A inverse. Now A square into any matrix into identity matrix is the same matrix. So this is A square, 6 A into I is equal to A plus 11I is equal to 6A inverse. Now therefore 6A inverse is equal to, substitute the value of A square. What is the matrix A square? So A square we have minus 1, minus 2, minus 4. A square minus 1, minus 2, minus 4. Again 5, 6, 4. 5, 6 and 4. Then 10, 10, 9. Then minus 6 times the matrix A, given matrix. What is the given matrix? Given matrix 1, 0, minus 1. 1, 0, minus 1. Again 1, 2, 1, 1, 2, 1, 2, 2 and 3. Plus 11 times I means 11, 0, 0, 0, 11, 0, 0, 0, 11. So simplify this, you will get the inverse for this matrix. Now let us simplify this. Now therefore 6A inverse is equal to, just keep this, minus 1, 5, 10, then minus 2, 6, 10, minus 2, 6, 10, minus 4, 4, 9, minus 4, 4, 9, then minus multiply by 6. So that is 6, 0, minus 6, 6, 0, minus 6, again 6, 1, 6, 12, 6, 6, 12, 6, again 12, 12, 18, 12, 12, 18, and the last one is, this is same, 11, 0, 0, 0, 11, 0, 0, 0, 11. Now what is this equal to? This is equal to minus 1, minus 6, plus 11, minus 2, minus 0, plus 0, again minus 4, minus into minus, plus 6, plus 0. Again this is 5 minus 6 plus 0, again 6 minus 12 plus 11, again 4 minus 6 plus 0, again 10 minus 12, 10, 12 plus 0, 10 minus 12 plus 0, again 10 minus 12 plus 0, again 9 minus 18 plus 11. Simplify this. 6A inverse is equal to, what is this equal to? Minus 6 minus 1 is minus 7, plus 11 is plus 4. 11 minus 7, 11 minus 7 is 4. 5 minus 6 is minus 1. So 10 minus 12 is minus 2. Again minus 2 minus 0 is minus 2. Yes, this is 11 plus 6. 11 plus 6 is equal to 17. 17 minus 12 is 5. Again 10 minus 12 is minus 2. 6 minus 4 is 2. 4 minus 6 is minus 2. Again 11 plus 9 is 20. 20 minus 8 is plus 2. So therefore the final answer A inverse is equal to 1 over 6 times the determinant, that is 4 minus 1 minus 2 minus 2, 5 minus 2, again 2 minus 2 and 2. This is the inverse for the matrix. So what is the inverse? So 1 over 6 into 1 over 6 times A inverse is equal to 1 over 6 times this matrix. Minus 4, minus 1, minus 2, minus 2, 5, minus 2, 2, 2, 2 minus 2 and plus 2 is the inverse. Hope you follow. This is how we are going to find the inverse using Cayley-Hamilton theorem in case of a 3 rows and 3 column matrix. It's a very lengthy and big problem, right? Hope you followed. Now let's move on to the next problem. So find the characteristics equation of the matrix 5, minus 2, 3, 1 and verify Cayley-Hamilton theorem. Hence find the inverse of the matrix. Same type problem, same as that of the previous, but this is 2 rows and 2 column. Now what is given? Let A is equal to, the matrix A is equal to 5, minus 2 and 3, 1. The characteristics equation is matrix A minus lambda I. That is, what is A minus lambda I? 5, 3, minus 2, 1 into minus lambda times 1, 0, 0, 1. So this is equal to 5 minus 2, 3, 1 multiply by lambda, lambda 0, 0, lambda. That's equal to 5 minus lambda 2, 3 minus 0 is 3 and 1 minus lambda. So now the characteristics equation now A minus lambda is equal to 0. That is determinant 5 minus lambda 3 minus 2 1 minus lambda is equal to 0. Now simplify this. That is 5 minus lambda 3 minus 2 1 minus lambda is equal to 0. Expand this. 5 minus lambda into 1 minus lambda, minus into minus plus, 3 2s are 6. 5 1s are 5. 5 lambda minus lambda, minus into minus plus, lambda square plus 6 is equal to 0. Put it in order. 5 first lambda square, minus 5 minus 1 is minus 6 times lambda. 5 plus 6 is plus 11 is equal to 0. So this is the characteristics equation. So the characteristics equation is lambda square minus 6 lambda plus 11 is the characteristics equation. So if you solve this, you will get eigenvalues or characteristics roots, right? So the roots of this equation are called the characteristics roots or eigenvalues. Now to verify Cayley-Hamilton theorem, put lambda is equal to A and multiply by I, identity matrix. So then this becomes A square minus 6A plus 11I is equal to 0. Let us represent this as equation number 2. Okay. Now find out A square. Now what is A square? A square is A into A. What is matrix A? A is equal to 5 minus 2, 5 minus 2, 3, 1 into 5 minus 2, 3. Simplify this. First row, first column, second column. 5 5s are 25, 2 3s are 6, 5 2s are 10, minus 2 1s are 2. Now, second row, first 5 3s are 15, plus 1 3s are 3. Again, 3 2s are 6, plus 1 1s are 1. That's equal to 25 minus 6 is 19, 15 plus 3 is 18, minus 12 minus 5. This is A square, right? Okay. Now, just substitute here. Now, A square minus 6A plus 11I is equal to A square. What is A square? 19, 18, then minus 12 minus 5. Minus 6 times A, 5 minus 2, 3, 1, plus 11 times 1, 0, 0, 1. That's equal to 19 minus 12, 18, minus 5, multiply by 6. 6 5s are 30, 6 2s are 12, minus 12, 6 3s are 18, 6 1s are 6, plus 11, 0, 0, 11. Simplify this. 19 minus 30 plus 11 minus 12, minus into minus plus 12 plus 0. Again 18 minus 18 plus 0. Again minus 5 minus 6 plus 11. What is this equal to? 11 plus 19 is 30. Minus 30 plus 30 gets cancelled, 0. Minus 12 plus 12 gets cancelled, 0. Minus 18 plus 18 gets cancelled, 0. Minus 5 minus 6 is minus 11 plus 11 gets cancelled, is equal to 0. So that is A square minus 6A plus 11I is equal to 0, a null matrix. Therefore, Cayley-Hamilton theorem is verified. Cayley-Hamilton theorem is verified. So, to find A inverse, we have A square minus 6A plus 11I is equal to 0. Multiply by A inverse on both sides. What you will get? A square into A inverse, 6A A inverse plus 11I A inverse is equal to 0. Just to find A inverse, multiply by A inverse on both sides for equation number 2. A square minus 6A plus 11I, that is A square into A inverse, 6A A inverse, 11I A inverse. A square can be written as A into A inverse. Don't change this as it is, plus 11 times I into A inverse is equal to 0. Since you know A inverse is equal to an identity matrix, A into I is equal to A matrix A itself. A into A inverse is I, 6. A inverse I is I, plus 11 into I into A inverse is A inverse. So, A into I is A minus 6I plus 11 times A inverse is equal to 0. Now, therefore, 11 A inverse is equal to transfer, plus 6 becomes minus 6 and plus A becomes minus A. So, substitute here, 6I means 6006 minus A. What is A? A is the given matrix. Given matrix is, what is 5 minus 2, 3, 1. 5, 3, minus 2 and 1. 5, 3, minus 2 and 1. Simplify this. So therefore, A inverse is equal to 1 over 11 times 6 minus 5 is 1. 0 minus into minus is plus. 0 minus 3 is 3 minus 3 and 6 minus 1 is 5. So the A inverse is 1 over 11 times 1, 2, minus 3 and 5 is the inverse. So therefore, the inverse for this matrix is 1 over 11 into 1, 2, minus 3 and 5. That's it. See, if you interchange the diagonals, 5, 1 becomes 1, 5 and changing the signs for the secondary diagonals, minus 2 becomes plus 2 and minus 3. That's it, the verification. This is how we are going to find the inverse for the 2 rows 2 column. So this is the method to find the inverse using Cayley-Hamilton theorem in case of 2 rows 2 column determinant or a matrix, and also in case of 3 rows 3 column matrix. So to find the inverse and to verify the Cayley-Hamilton theorem in case of a 2 rows 2 column and 3 rows 3 column matrix. These type of problems are very important for the point of examination. So hope you followed. So that's all regarding today's session. Let us meet with a different concept, that is regarding the rank of a matrix, in the next session. Thank you very much.